Okay, we're going to discuss data visualization using Seaborn. And actually, this comes from a book here, which is called R for Data Science, which is using um, R as opposed to Python. So hopefully, uh, this document here mimics that same book. This is actually chapter one of this book here, Data Visualization. It's chapter one of this book. And this is a kind of a Python version of the same concepts. Now, in here, of course, they're using R, so they don't have the same uh, modules, or in R they're called packages, but they don't have the same ones in R. And this is based on a package called this ggplot2, but of course that doesn't exist in Python. But in this tutorial here, we'll sort of reference ggplot2 because we're going to be sort of working off of this tutorial. So we'll say, for example, in ggplot2 might do it in one way, but in Seaborn you do it in a slightly different way. So that in that sense we'll be making reference to ggplot2. Of course, this is not about ggplot2. It's just that this text happens to be using ggplot2. So let's go through a little of that first. So first of all, we start out with this quote from John Tukey. And actually, I'm not sure how to say that name, but a very famous statistician. And he said, "The simple graph has brought more information to the data analyst's mind than any other device." So he's saying that when you visualize data, our mind works with images, doesn't work with, spreadsheets. We can't really get a lot by looking just at a spreadsheet of data. But as soon as we see a picture of that data, boom, we get a lot of understanding of the data. So he's saying that graphs um, are a very powerful way to understand data. They're powerful in the sense that our brains are powerful and we can utilize our brains when we get pictures. So, in that sense, graphs are very powerful. So let's go on. Python has several uh, systems for making graphs, but Seaborn is one of the most elegant and versatile. Seaborn builds on Matplotlib to provide a high-level interface for statistical graphics. So high level means like easier to use than even Matplotlib is. With Seaborn, you can do more and faster by learning one system and applying it in many places. This guide will teach you how to visualize your data using Seaborn. We'll start by creating a simple scatter plot and use that to introduce aesthetic mappings and plot types. So we'll have to see what that means later. The fundamental building blocks of Seaborn. We'll then walk you through visualizing distributions of single variables as well as visualizing relationships between two or more variables. So we might just look at one variable and sort of visualize it, or we might try and visualize two variables together to see if we can understand how they sort of relate to each other. Like, for example, are they strongly correlated? Something like that, or maybe more than that. We'll finish with practical guidance on saving your visualizations and troubleshooting common issues. To access the data set, so we have some built-in data sets that we're going to use, and also to access the help pages and functions used in this guide, you'll need to import several packages. So we need pandas. Pandas is like kind of like Excel. I mean, in the sense that it allows you to sort of store your data in a kind of a spreadsheet format, which they usually call a data frame, or it might be called something else in Pandas, but basically I think it's called a data frame, and which is just a spreadsheet. So that's useful. And then we're going to Seaborn and also Matplotlib, which we're going to access as PLT, and Seaborn we're going to access as SNS. So Pandas for data manipulation and analysis, Seaborn for statistical visualizations, and this for customizing the plots. If you run this code and get an error about missing packages, you'll need to install them first using pip. So we can do that with pip here. You have to run this, of course, in the command line or in a terminal. For this tutorial, we'll be using the Penguins dataset from the Seaborn library, which contains body measurements for 3 species of penguins. Okay, just skipping down here for a second. So the species are these. So I'm just curious. I haven't even looked at what they checked to see what they look like. So let's just see what they look like. So penguins and, well, I don't know. Oh, here. This one, and this one. So I can't tell any difference between them. But maybe there's some differences. Maybe this one seems to be bigger. I don't know if that's just by chance or if this type of this species of penguin is actually bigger. So actually here looks like there are some differences in sizes of penguins. The penguins data for here. Sorry, let's not skip. So I guess this is available in the Seaborn package. So we can get it by doing sns.load dataset and then penguins. And we'll get that dataset. And we'll store it as penguins. Okay, so it's very good when you're doing visualization to ask questions and then try to get the visualization to help you answer the question. So let's see what questions they pose here. So first steps. Do penguins with longer flippers weigh more or less than penguins with shorter flippers? Well, you might say, oh, of course they're going to weigh more because the flippers are longer, but who knows? Maybe it's not true. You probably already have an answer, but try to make your answer precise. So I'm not quite sure what that means. What does the relationship between flipper length and body mass look like? Is it positive, negative, or linear? In other words, if we had the x-axis is, actually I'm going to change this. So what they're asking is, if this is flipper length, and this is body mass, as the flipper gets bigger and bigger, this doesn't work too well. Oh, there it is. Okay. Anyway, as the flipper gets bigger and bigger, does the body mass also increase or not so much, and so on? Okay, here's a better picture. So does it look like that, or does it look like this? So as flipper length gets bigger, body mass decreases. So what does it look like, or is it positive, which is like the blue one, or is it negative, which is like the orange one? Is it linear, or is it curved? So maybe it looks like this. So is it curved like that? So that's the question we're asking. How about by the island where the penguins live? So we might have data about the island, and maybe that has one of these kinds of relationships. So let's create visualizations that we can use to answer these questions. Okay, so we have 344 observations or rows of data collected and made available by this person and this place in the Antarctic. Okay, so first thing we can do is get some info on the penguins. So apparently in Seaborn, remember this is a Seaborn data set. So Seaborn you can do on such a data set. You can do .info, and apparently that will give you something. So what will it give you? It will show you uh, that that penguins contain 8 columns, and the key variables that we will focus on. So it's going to give us 8 columns of data. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, or something like that. It's going to give us 8 columns of data, and we're going to focus on the flipper length in, I guess, in millimeters, the length of a penguin's flipper in millimeters, the species, sorry, I skipped the species, which is either this, or this, and the body mass, which is in grams. Okay, to help understand the data, let's define some terms. So a variable, I think we know what a variable is. Each column is a variable, and it's either a quantity, meaning it's a number, or it's a quality, like this is not a number, and this is not a number, and this is not a number. So species is the variable is not a quantity, it's a quality or property. So we can call these properties or names of something like that. It's not a number or property that you can measure. Okay, so a value, okay, we're going to use the word value to mean the state of a variable when you measure it. So, I get a flipper length of 62, so that's the value. Or if I'm talking about species, the value is either this, Adele, I don't know how to say that, chinstrap, or gento. So those are called the values for the species variable. Um, an observation, yeah, so we said these are the columns here, column. I mean the labels for the columns, so this might be species, and this might be flipper length, and might be body mass, and then we have other columns as well. But those are called the variables. The columns are the variables, but the observations are the rows. So we have the first row, the second row, the third row. We call it the first observation is this whole row. The second observation is this whole row, and the third observation is this whole row. Or if you want to be a little bit more precise, sometimes we don't really mean the row, but we mean the bird. So, we have one bird. This is one bird. And then we have a second bird. I'm not very good at drawing. Second bird. And then we have a third bird. So the observation is the first bird, the second bird, the third bird. And then, the first bird has a set of values for the variables. The second bird has a different set of values for the variables. And the third bird has a different set of values for the variables, and so on. So the observations, actually, I'm not sure which language he's using. We could say he might be saying that these are the observations, the bird is the observation, or he might say that the row is the observation. So you might say, who cares? So maybe we don't have to care about it. But anyway, okay, he says, sorry, an observation is a set of measurements made under similar conditions. So what does that mean? So in this case, we have this bird, we make all the measurements. They're all for this bird. Then for this bird, we make all the measurements, so it's for this bird. So under similar conditions means in this case, one bird we get these measurements, a different bird we get these measurements. The different conditions are the different birds. So actually he's saying the observation is the row, not the bird. Okay. And tabular data is a set of values each associated with a variable and an observation. So this is tabular data. It looks like a spreadsheet. Okay, so we can preview the first few rows by looking at the head. So penguins.head and print it, and we can see what it looks like. Now, we don't see what it looks like here, but I'm going to switch back to that tutorial that I said this is taken from, and maybe we can see some of this there, although, it's not using Seaborn, it's using an R-based package, so the command is not going to be necessarily the same. Okay, but maybe it will be the same. So going back to here, this is not what we're doing. We're not using those. So they're talking about the Penguins data frame. So here it's called a data frame. In the other case, we might call it a data frame or a data set. Here we are making the distinction about variables, values, observations, tabular data. And here we can see some of the columns and rows. So species, and what island does it come from, and what's the bill length. That means that's the I guess that's the same as the beak, and the bill depth, and the flipper something or another. So those are the different columns, and we can see that in this case, you don't have to do dot head, where they're not doing dot head, and I guess, but you're getting a bunch of the information. In Seaborn, you would have to do penguins.head to see something like this. You'd see the first 6 rows, and you'd see all the columns. Here, it doesn't show you all the columns because it doesn't fit nicely on the page. And in R, there's also something called glimpse, which I don't know, gives you a little different set of information about. Guess look, these are the variables are now sort of they're the row names actually. That's like a different way to look at the data, but we don't do that necessarily. Okay, so coming back to here. So Seaborn provides several main plot types. So we have relational plots or scatter plots. So that means you have 2 variables, for example, and one of them might be, what did we say we had? Flipper length and body mass. So let's say flipper length and body mass. So that's 2 variables. And then you have dots, like that, for example. And that's called a scatter plot. Okay? And that's a relational plot because you're looking for a relationship between these 2 variables. Now, one thing that you should, whenever you look at a graph, I always recommend that the first thing to do is to look at the axes to see what they are. Now, maybe you already know what they are, but just to make sure, or if you don't know what they are, you should always check the axes of a graph. It kind of gets your mind in the right frame to think about what you're looking at. Okay, and then also, here we have dots. So what does this mean? What are these dots? What is this dot? What is this dot? So each dot here is what each row represents. This row is our measurements of this bird, and this row are measurements of this bird. And each dot is a bird here. So this is one bird, this is another bird. So this bird has a flipper length of this and a body mass of that. And this bird here, has a flipper length of this and a body length of that. So each dot is a bird. So that's something you have to, at least I have to think of consciously. What are the dots? What do they stand for? What are they? And then also, as I said, what are the axes, or what are and the axes are 2 different variables. Now we have, I think they said 8 variables, so we don't have to use just these 2 variables. We could look at how flipper length is related to some other variable, but here we're doing how it's related to body mass. Okay, so this type of graph, scatter plot, and I guess some kinds of line plots are what are called relational plots, because we're looking for the relationship between 2 or maybe more variables. Because we could have 3. We could have 3. Let me draw another one here. We could have 3 axes, right? Of course, everybody's seen 3 axes. This is the 3rd dimension. Comes out like this. right? So now we have 3. So we could have a 3-dimensional scatter plot as well, but we're not talking about that now. Okay, so distributional plots are different. So that's usually just one variable. Um, and you look at how, like for example, we could look at just flipper length, and we could do what's called a histogram. And we could say, or not a histogram, sorry, we could do like I'm not sure, what do we call it? A distribution graph. So maybe this flipper length is, I don't know what flipper lengths are, but let's say this is 50, and this is 100, and so on. And maybe the distribution looks something like this. Something like that. So what do I mean? What does this mean? It means that there are like a lot of birds that sort of have 50 and a lot of birds that have 100. And otherwise it sort of drops down. There aren't so many in this range and less over this way and less over this way. So that's the distribution just of flipper length. So this is not comparing 2 variables. It's just one variable and looking at the distribution of it. So that's another kind of graph that we would like to be able to draw with Seaborn. And then there are other types here, KDE plot and box plot and categorical plots. So that means that here, flipper length is a quantity. It's not a quality. But we did have a variable that was a quality or a property, and that was this one. And it only has these 3 different values. It doesn't, flipper length can take all kinds of values. It can be down here, it can be between here and here, it can be between here and here, it can be anywhere. So it has many, many, many different values, but that's not true about this this variable here. Species can